Solving linear systems using technology is section 2.3. So we're looking at matrices. I know you may not have heard about matrices, but it's something that's really, really easy. So let's go ahead and see what we can find out about them. We are going to write an augmented matrix for a system, and then we're going to state the dimensions. So before we can get started writing an augmented matrix, we need to rearrange so that the x is first. And the way that we're going to do that, right here, we're just going to switch the place of the x and the y. So let's rewrite that as negative 2x, because the negative must go with the whole term. The y is positive, so plus y equals 1. And then x plus 3y equals 12. The way we're going to write this augmented matrix is we are going to pull the coefficients in front of each variable. So the coefficient in front of the x is negative 2. The coefficient in front of the y is a 1. And then the number on the end, the constant on the end, is a 1. Second row, we have a coefficient of 1 in front of the x. We have a 3 in front of the y and a 12 on the end. Where our equal sign is, we are going to put a dotted line, and then we're going to put square brackets around it. That's all there is to writing an augmented matrix. So now it says state the dimensions. Dimensions are m by n, or rows by columns. Rows go sideways like pews. So we have 2 rows here. Columns are like the pillars on a porch or the columns on a porch. They go up and down. We have 3 of those. So our dimensions are 2 by 3. All right, and that's all there is to that type of problem right there. That's kind of just getting us started. Let's look at example 2. Example 2 is a little larger. Write an augmented matrix for the system. State the dimensions. It's the same directions. It just looks a little different because we have a 3 equation system. Also, in the first one, if you notice here the note on the side, all variables must be on the left and in order. So right here, I've got a negative 2z on the right. So let's go over here and rearrange that. If I have 3x minus 4y equals 7 minus 2z, then I'm going to add 2z to both sides. That way I can get all my variables on the left. Write them in alphabetical order. 3x minus 4y plus 2z equals 7. So now that that's all on the left, let's rewrite the entire system. 3x minus 4y plus 2z equals 7. That was the first equation, so I'm writing it first. Second equation, 9x plus 3y. There is no z, so I'm going to put plus 0z as a placeholder. Equals 3. Last equation, 2x plus 4y minus z equals 2. Let's get the augmented matrix for that. So we have 3, negative 4, 2, and 7 in the first row. Second row, 9, 3, 0, 3. Third row, 2, 4, negative 1, because the negative goes with it, and 2. Make sure you write your dotted line where the equal sign would go. Put your brackets around it. Our dimensions here, we have 3 rows by 1, 2, 3, 4 columns. So that's a 3 by 4. And there's our augmented matrix for that. All right, so now, solving a linear system using technology. Step 1, write an augmented matrix for the linear system. Step 2, enter the augmented matrix in your graphing calculator. Step 3, use reduced row echelon form feature to rewrite your system. Step 4, interpret the result from step 3 and solve the system. So here's your calculator steps. First, you're going to go to a regular calculator screen where you're just going to do 3 times 2 or something like that. Go to Menu, 7, which is matrix and vector. Got my words mixed up there. 5, reduce row echelon form, and it's going to look like this on your screen. Click the button to the right of the 9 and choose the largest matrix input your dimensions, press enter, input your numbers, and press enter again. So let's look at that right here. So with example, this is supposed to be example 3. Sorry about that typo there. Example 3, use a graphing calculator to solve the system. So we have A, x plus y plus z equals 2, 2x plus 3y plus z equals 3, and x minus y minus 2z equals negative 6. So the first thing that we need to check is to see if we are in the right format. Are all variables on the left side? Yes. Are they all in order? And yes, they are. So let's go ahead and write an augmented matrix for this system. We have 1, 1, 1, 2, 2, 3, 1, 3, 1, negative 1, negative 2, and negative 6. Make sure you put your dotted line in there for where the equal sign would be. Now, let's go back and use those calculator steps. So on this calculator, we are going to go to a regular calculator screen, menu, 7, which is matrix and vector, 5, reduced row echelon form, and it gives us this right here, RREF. Then you're going to press that little button right there beside the 9, and you're going to choose this right here, that largest matrix, and change your dimensions. So we had 3 rows, we have 4 columns, and there we go. Now we can just input our numbers. So inputting these numbers, we have 1, 1, 1, 2, 2, 3, 1, 3, 1, negative 1, negative 2, and negative 6, and press enter. This right here is what we call an identity matrix on the left side, the 1, 0, 0, 0, 1, 0, 0, 0, 1. As long as that entire left side looks just like that, that's what your answer is going to look like. So we're going to write that down. Let me move the calculator real quick. So then our answer right here is going to look like still a matrix, 1, 0, 0, and just a second, let me pull that back up for me. Negative 1, 0, 1, 0, 1, 0, 0, 1, 2. Put that dotted line in there where the equal sign should be, and this one is in the x place, this one is in the y place, this one is in the z place. So that's where our answer is going to come from. Negative 1, 1, 2. And that's all there is to that. When you write this right here, you may want to go ahead and put RREF because this is what you're putting in your calculator. All right, let's look at another one. B. So I'm going to go ahead and write down RREF. Everything looks to be in order. Write down my augmented matrix. 1, 1, 1, 9, 1, 1, 1, 3, 5. There is no y, so I'm going to put 0, negative 2, and negative 1. Put my dotted line there. Equals. Now let's bring that calculator back up. We're going to go to menu, 7, 5. Click that button beside the 9. Choose the largest matrix, change your dimensions, and input your numbers. So we have 1, 1, 1, 9, 1, 1, 1, 3, 5, 0, negative 2, negative 1. Oh, that helps if I put in the right thing. Don't put in a decimal. when you need a negative. Okay, so look right here. This looks a little bit different. We have 1, 0, -2/5, 0, 0, 1, 7/5, 0, and 0, 0, 0, 1. This is where our dotted line would be. This is our matrix. Okay, so the problem here, we have some fractions in there. We don't have an identity matrix. On the left side of that dotted line, we have all zeros, and then there's a number on the right. That's the key factor right there that makes this a no solution. Okay, so the numbers right here on the bottom all being 0, except for on the right side, there's a number on the right. That right there makes this a no solution. All right, now let's look at one more, and this will be our last one. Record time here. C. Let's go ahead and make our augmented matrix. Look, everything's in order. We have x, y, z on every single equation. First row, 1, 1, 2, 10. Second row, -1, 2, 1, 5. Third row, -1, 4, 3, 15. Put your dotted line in and put that in your calculator. All right, when you put that in your calculator, menu 75, 1. Whoops, what did I forget? I forgot to put that in there. So let's go to the button beside the 9, choose here, 3 by 4. All right, here we go. 1, 1, 1, nope, 1, 1, 2, 10. -1, 2, 1, 5. -1, 4, 3, 15. And I need to change this from a decimal to a negative. All right, so all of our numbers are now correct there. Press enter. And now we have this answer, 1, 0, 1, 5, 0, 1, 1, 5, and 0, 0, 0, 0. So this is a little bit different from the last one. We still don't have an identity matrix on this left side here, and we have a row that's complete and total zeros right here. That is going to be infinitely many solutions. Try to squeeze that S in over there. Whoops. I just messed it all up, didn't I? Okay, infinitely many solutions. And there we go. Make sure we highlight everything there. And we're done.